So as described, I'm with the LÖVR project. We are an open source VR engine. We're going to have two talks for you. I'm going to give you a talk about LÖVR in general and a game that I am making with LÖVR. And then Nevin Bengtson has sent a video of something called Alloverse. I have actually not seen the video, so I'm curious about it, which is some kind of like metaverse Second Life thing based on top of LÖVR by Nevin's research group. LÖVR is an open source project run by Bjorn Swenson, who wrote most of the code. And this talk is not going to be exclusively about LÖVR, because when DCG came to us and said, hey, we want to see something that's just cool stuff that's happening in VR, I figured maybe I should do just kind of like a brief overview. So in this talk, we're actually going to do a brief overview of just how you make VR games in general. And then I'm going to show a demo of LÖVR, which is our project. I'm going to show my game, Skate Girl Destroys the Universe. I'm going to talk a little bit about how I use LÖVR, and then if we have time, we can do some questions. So about me, I have a background in making... About me, I have a background in making experimental video games, which I usually give away for free on the internet. They're usually based on psychedelic visuals, weird, pushing computational systems to their limits, that sort of thing. What I'm working on now is a game called Skate Girl Destroys the Universe. I've started a video game company, Mermaid Heavy Industries, and I'm trying to do this for serious now instead of just as a freeware hobby. So I'll talk some more about Skate Girl in a minute. First, let's talk about game dev. So if you're not familiar with game dev, this basically is what game dev looks like in the year 2021. Sort of most of the work, I'm going to show you a few different game dev systems over the next minute or so. And they're all going to look like this, except for LÖVR. They all follow this notion of kind of you have an editor. The editor is based on scenes or something like scenes. In the scene, you have this, you can see way over on the left there, there's a pane showing main camera direction light cube. You have a series of entities in these scenes that you can move around in this editor space. You can click on one and there's this usually fairly dizzying list of options on the right-hand side. Most game development platforms have converged on this sort of editor model. This is actually not the model LÖVR uses. This is the model LÖVR uses. In LÖVR, if you want to draw a cube, you call the cube function. So LÖVR is a more of a code-based engine, maybe a little bit of a throwback, which is an immediate turnoff to some people and an immediate enormous relief to others. It just depends on what you prefer. So going over those options I mentioned for VR game dev, the most popular game dev tool, especially in VR, just anywhere right now, is this program called Unity. It is something that started off as kind of like a thing for making indie FPSs about 10 years ago, and it is just absolutely in the world. Pros of Unity, the fact that it is popular actually is a pro unto itself. There's an enormous ecosystem of people who use Unity, contractors who use Unity, assets on the asset store for Unity, libraries for Unity, almost anything you might want to do, there's probably an asset for it on Unity already. This is especially important in the VR space because support for VR platforms, a lot of VR manufacturers, not to name any names such as Facebook, but have a tendency to, when they want to add VR support, release an API for their VR platform, they will tend to do so just by releasing a Unity plugin and assuming, okay, we're done. And if you are, writing your own program, for example, not based on another engine, or you are developing an engine, you're left with like, here's some uncommented, undocumented C header files, just go have fun. So if you're using Unity, you are on the golden path for basically any VR engine that is going to be coming out. The downside with Unity is that Unity is, as mentioned, something that kind of barreled out of control from an indie FPS engine about 10 years ago, and it does not have what I would call sound technical underpinnings. It's a bit messy, it's a bit buggy, it's very out of date in certain ways, and Unity's attempts to update it have mostly looked like they have the old system that they've had for 10 years. It's a bit crufty, it has some problems. So they introduce a new system because they don't want to change the old system and break everyone's code. They introduce a new system. And the new system then lives alongside the old system with everyone using both and not being sure which of 3 different graphics engines and which of 3 different animation systems they're expected to be using. That can get kind of confusing. A lot of the time you wind up using the old system and just wishing that you could use the new system. So a lot of people I know who use Unity spend a lot of time complaining about it, but they also get things done very, very, very quickly. So my advice for you, if you use Unity, use the LTS version, the long-term support version, and if you're doing VR, use VRTK. It's a bundle of very, very useful VR tools for just doing things like, do you want to attach a component to an object and make it so you can pick it up with the VR handset now? Do you want to make a 3D, make like a UI floating in the background that you can like hit buttons, that sort of thing? That's all part of VRTK. Is there a problem? Okay, we're good. So Unreal is the other big popular commercial engine. This was based on the Unreal games, Unreal Tournament, those sorts of things. They commercialized this product, and VR Unreal, as opposed to Unity, Unreal has really, really good technical underpinnings. Just like I have a lot of admiration for the way that Unreal is architected. When you look up like how does this work, it's always something really. It just makes a lot of sense. They have very, very good visuals. If you open up an Unreal project, to say new project and drop a cube in, that cube will be gorgeous. That will be a cube that Salvador Dali could have painted. The problem with Unreal is that with all of these great, well-architected systems, it's actually a very large thing. It is difficult to learn Unreal. Unreal was something that for a very long time was used inside of large game development companies, and they've only recently started looking at the individual market, the indie market. So if you want to learn Unreal, my advice is to go work for Ubisoft for 3 years and learn from the Unreal person on your team. One other thing to note about Unreal, you've got, Unity you develop using C#, which is in some ways good and in some ways bad. Unreal you develop using either C++, although that's mostly discouraged, or something called Blueprints. Blueprints are awesome, Blueprints are terrible. Blueprints are a visual scripting language that you use in Unreal to you basically sort of write code or write graphics shaders by connecting, like drawing flow diagrams, basically. You connect boxes to lines, and you can basically program an entire game using just blueprints. A lot of artists actually find this a really, really natural form of programming. It is really neat. The problem is if you want to do something complicated enough that blueprints isn't going to cut it, you might still kind of be stuck in blueprints. You either have to go to the C++, mode, which has a lot of its own problems, or there's like some plugins. There's a plugin that lets you do JavaScript with Unreal, but it has a lot of problems, and its documentation is written in Korean. So if you happen to speak Korean, which I unfortunately do not, I can highly recommend Unreal.js. So moving on. There are 2 more quick options of open source Unity likes, Godot and Play Canvas. I don't actually know very much about either of these. I tried Godot briefly about 3 years ago, and at the time I didn't use it because their 3D support was at the time kind of embryonic. However, that was 3 years ago. Their 3D support looks very, very good now. Play Canvas, meanwhile, is it is Unity-like, but it is based on JavaScript. You can run Play Canvas in a browser, meaning the editor runs in a browser, and then the game is run in a browser. And all of these things I've just shown you, they all support VR out of the box. Play Canvas does it using WebVR. So that is everything except LÖVR. This is LÖVR. So LÖVR is the project I'm on. It is compared to even Godot, it is a fairly small open source project. Most of the code was written again by Bjorn. I would say that there are enough users of LÖVR that I probably still recognize all of them by their Slack handles. So I'm not necessarily going to convince you to use LÖVR. I'm going to say this is why I use LÖVR, and going to from here try to give you a sense of what VR game dev is like using LÖVR as a lens. So what I like about LÖVR is that LÖVR is very simple. It's very extensible. If you prefer to write code, which I do, LÖVR does not get in your way. It lets you just write code, get the things you want to get done. If you are okay with forking the internal C engine, it is very clean and very easy to fork. The downside of LÖVR is that it is a smaller scope than any of these other games that I've mentioned, game dev engines that I've mentioned. There is no editor. Certain libraries are not, certain libraries that you would just have in Godot are not present. You might have to write them yourself. We do have a suite of third-party plugin libraries, both C plugins and Lua plugins for LÖVR. I've written some of them, but there are some things that aren't present. But if you're okay with doing some coding yourself, it is great for that purpose. So I'm going to show you, I'm going to do a demo real quick, just show you what writing LÖVR is like.
Praying for the demo gods for you.
Oh, I practiced this a bunch. I'm not worried about anything other than my audio. So a LÖVR program is just a folder full of files, or a zip file full of files. So you'll notice we've got here two files, conf.lua and main.lua. Don't worry about conf.lua. That's only there so I can plug in to OBS. So let's make a game in LÖVR very quickly. Cooking show style, I've got something I can paste in for another window. This is pretty much it. So I'm going to go over here and launch in the command line. You don't have to run LÖVR through the command line. It's just what I am comfortable with. You could also just take the folder and drag it onto the exe. It works like a flash projector. For those of you old enough to remember Flash, AIRP members, that sort of thing. You notice I typed in here LODR. I'll explain what that is in a minute. But so let's see here. Here's our little game. It usually takes OBS a minute or so to pick up on the fact I've booted there we go. So what we have here is just a very, very simple program, and all it does is LÖVR works by these callbacks. So it calls a function at load time. It calls a function once a frame with the time step. It calls a function once a frame to draw. Everything is very, very simple. It's just call your function, get out. So what I'm doing here is I am preserving. I've got a time that I am updating with the how much time has passed on every frame step, and then I am printing out what is the current time. So this looks kind of ugly. Let's try to clean this up just a little bit. Let's say no. Do some printf type stuff and save. And because I'm using loader, which is the hot reloader, it just immediately bounces the changes over to the game over here. So what you're looking at this in is our desktop simulator, because it is actually kind of difficult it's actually a little bit difficult to plug in a VR game to a streaming program like OBS, and also it's a little bit hard to stream when you're wearing a VR helmet. So I'm doing this in the desktop environment where you've got kind of like a WASD control. It actually might be kind of hard to tell if this is a 3D environment at all. So let me add one more thing over here. I'm going to add some lines. So we've got a floor around our time, and let's do something interesting. Let's make the time rotate. I'm gonna add 1 for 1.0 scale, and then I'm gonna say this is the rotate argument, so it will just rotate with time t. Okay, that is not how I meant for it to rotate. So let's set a different. Oh, sorry. Incidentally, we do have errors in VR. If I was wearing the VR helmet while this was going on, I would just be facing a black void with syntax error unexpected near comma. It is like the most cyberpunk thing I've ever experienced, is that I'm just like using my VR game and suddenly I'm staring at a giant error. Yeah, so here's a tiny little VR game made in a minute or so with LÖVR in the simulator. And this is just me controlling it 3D WASD with the keyboard. But if I was running in VR mode instead of running in simulator mode, I could just put on the helmet and be like, I spend a lot of time developing with like the helmet up in my head, typing, saving, and then pulling down the helmet to see how things changed. So that's a simple demo of LÖVR. Let me show you something complicated that you can do with LÖVR.
I know you're on a roll, but I just want to bring up this because I'm stupid. So are you like trying to stream this entirely through your webcam? Because I realized I was dumb and I forgot to put you as a presenter in the program itself. So I'm gonna switch over to that because you're doing great. It's just the desktop part it's hard to read because it's blurry. Like people could see the VR stuff but not the code, and that's probably because I'm an idiot and I forgot to put you in presenter mode. So let me do that.
Okay. Well, let's back up a little bit then.
Let's see here.
Sorry about that.
No, that's
I obviously can't watch the stream and stream the stream at the same time.
Right. No, that's why I'm here, because I didn't want to interrupt such a great role.
No, it's fine. But yeah, you should.
So I just put you in presenter mode, and so I think you should be able to directly share your desktop as a separate thing.
Okay.
That might make it better.
I can't share the desktop. I've got it. It's coming out of the OBS virtual camera.
Okay.
Can you? Looks like it's a little bit.
It also just might be a limitation of bandwidth between our two locations.
Yeah, that's rough. Okay,
but I just wanted to make sure that I gave you all the options because I've done like that occasionally. Right, that's what I mean. You can't do anything.
Yeah,
Just keep going. I just want to make sure I gave you all the options.
All right. Well, it's now, and you may or may not be able to read. You may not be able to read that text, but this is just a very, very simple program. So I don't know how well this is going to stream, but let me try to show you. Let me try to show you my commercial game that I am developing with LÖVR. I'm gonna make this video a little bigger. We have not announced what platforms the game is on yet, but this video was captured on the Oculus Quest. LÖVR supports the one where just a small open source project. One place we are very good is we have support for lots and lots of different platforms. Can you hear both me and the music from the game at the moment?
Yes, that's perfectly fine.
Okay, great. So. Yeah, I could try to release. I'm actually recording a video of this, so maybe I'll try to put together a video later. So the idea of this game is that you are Skate Girl, this little eyeball person in the corner here, and you are moving around on these TV screens that are floating out in VR. I don't know how much you can see. Audio's fine, great.
You can see it overall.
You're moving around on these TV screens, you're moving between the TV screens, but the thing that makes the game interesting is that you are also able, using these little VR controllers, to reach out and just grab parts of the world and move them around. So each of these little screens has its own little 3D world on the inside. It's bigger on the inside, and you can fit them together like puzzle pieces. So the idea is that I wanted to, when you look at these VR controllers, you've got kind of like a cross between kind of like a direct manipulation controller and a video game controller. You've got like kind of half a dual shock here. So I wanted to do something that let you use both the kind of like video gamey, buttons and joysticks part of VR, but also let you do the direct hand manipulation, let you reach out and use your hands, grab things, move them around, be actually doing things with your hands. And the thing that's really cool thing about this is that this game lets you kind of be creative, sort of. So like, you can put together the parts of the world in lots and lots of different ways, but some of them won't work. Like here, I've tried to connect this upside down, just go right to the exit, and you can't go right to the exit. You have to, it's like you are the game designer while you are playing this game, and you have to design a level that you are able to beat. So this particular level here, there are a lot of different ways to resolve this level, actually. Some of the pieces aren't actually necessary. So here we have it. We have the complete solution of the puzzle where we've plugged all the screens together and you get all the way from the start to the end. Yeah, and there you go. And I got killed by a bat. Okay, so
It happens.
it happens sometimes. And I got killed by a shark. I had my flow down. I don't know if you can tell this, but like the music is actually changing dynamically as you do things in the game. It responds to every time you jump, every time you connect things together, when you go from level to level. I'll talk about that a little bit more in a moment. Does LÖVR work with Google Daydream and Cardboard? So LÖVR works with OpenVR, so Vive. It works with hold on. I'm sorry, just trying to find. LÖVR works with OpenVR, which is Vive. It works with Oculus VR on the desktop. It works for Quest VR. It works for two other Android platforms that I'm not familiar with, Pico and something else. Thank you, Setsune. It works with OpenXR, which is sort of the future, and it works with WebXR. Daydream and Cardboard. The problem with Daydream is that Google has dropped support for Daydream. So we were very interested in supporting Daydream, but it's a discontinued product, and it's very difficult for us to target a discontinued platform. For the same reason, we used to have support for Samsung Gear VR. We dropped it because Samsung discontinued Gear VR, although you can still get it if you use an older version. Your best bet with Cardboard at the moment is probably to use WebXR, that output. But if you want to, like, our ability to port to platforms is just basically only limited by what platforms we have access to. So if we had a user that was using Cardboard, we could get it working with Cardboard. But without a tester, we can't really make that work. Moving on a little bit. Why do I like LÖVR? Sorry, I lost track of my slides answering that question. The reason I use LÖVR is that I am a C programmer, and to me, LÖVR is very, very extensible and very easy to change. So LÖVR is set up as a series of modules, and you could turn off whatever combination of those modules you need. You can actually turn off the VR part of LÖVR if you want, and I'll say a little bit more about that in a bit. But as a C programmer, I've been working with Lua-based engines for a long time. I used to use one called Polycode. I actually have my own kind of variation of LÖVR, which is built in Lua on top of LÖVR. Lua is an extremely versatile programming language. You can do lots of meta-programming in it. There is no object-oriented system in Lua, but you can load object-oriented programming through a library. I've never seen a programming language that lets you do that before. Just like, I wish that this programming language had classes and objects. I'm just going to add it. Just going to add that. This particular screenshot, it uses a namespace library that I wrote, just added namespaces to the language. you're going to have trouble reading this. So I'm going to make the text bigger. If you were able to read my example code earlier, this is the same example code written using LÖVR int. So in normal LÖVR, you have a load callback, you have an update callback, you have a draw callback. In this, you create an object that has a load callback, an update callback, a draw callback. And what's nice about that is that you can have kind of multiple apps running at the same time. You can have apps that are, you can have like objects that are children of other objects. So like when you're running Skate Girl, you've got this kind of top level loader entity, but then you've got you have the runner entity that is doing all the game logic, but then the screens are controlled by this mech mode object that gets cycled out after every stage. The screens in the background are being handled by their own object because those are actually happening in a compute shader. And then the audio has its own object, and I can just plug all these together however I want. If you look, this actually looks a lot like the entity tree in Unreal or Unity or any of those kind of more editor-based languages. We just don't have an editor, although you could write one, because what I've really enjoyed about this way of using things is, so I'm going to just run the actual game here. Is this working? Please?
We know your pain. We know your pain.
Yeah, it's there we go. Yeah, so I can just boot up the game here, but alternately what I can do is when I run the game, I can load up several of the entities at once. So I can run, hold on. So I'm going to add 2 debug apps to run at the same time as Skate Girl. I'm going to run the FPS app, and I'm going to run a floor app. And when I just load all 3 of these at once, I've got, yeah, when I run all 3 of these at once, I've got the game running, but I've also got an app that just draws a floor here, so that if you're not, before we had like, we had to go back and add those lines so you could see a floor. This is just a little test thing for drop a floor on top of whatever else is happening. I've also got an app that is displaying, you can see in the corner there, the frame rate that I'm hitting at any one time. And I can go pretty far with this. In fact, I built an entire editor for the game using that. This is how I'm developing Skate Girl, hold on. Yeah. So here I've got, this is the editor that I'm actually creating Skate Girl itself in. I've got like a listing you can see for, there's like 3 floating screens in this window, and I've got an editor. I can select one of them. I can like change the color of one of them if I want. And I can just go over here and start editing stuff. And this is all stuff I wrote myself, but the important thing is that because LÖVR is a simple extensible engine, I was able to write all this stuff myself. In Unity, there's an editor. You use the Unity editor. Here, I just made my own editor, and what's really cool here is that I could, if we were in VR mode, which again it's hard to stream, if we were in VR mode, I could just be, have the headset on while I'm editing stuff, or I could have a tester sitting there editing. They could be moving Skate Girl around, and I could just go and like, drop a bunch of snakes on them or something. So like, hold on. Sorry, I had to move Skate Girl to safety.
That's fine. I just wish I could drop a bunch of snakes on people in real life sometimes.
Well, this is the power of VR, but as our previous talk showed us, it is also the danger of VR, that people might be dropping snakes on you. So this is my reason for using LÖVR, is that it gave me, as someone who is a little bit more experienced with programming, the freedom to do stuff like this. If you're maybe not as much as a hardcore programmer as I am, you could look at Unity or look at Godot, and they might give you some of these like editor-like features for you. So this is most of what I have to show, but I have 2 more things. I have a couple more things I want to run over real quick. I want to go over. I want to mention that the generative audio, the thing where it's reacting to what you're doing, it was done by Isaac Schenkler, who's the composer I'm working with. We've got there's a list of the people who worked on the game on our website, but which you should watch if you want to see when we announce a release date. But all the music is done with something called Pure Data. So this is actually a display of how the Pure Data script that is doing all the music. And anytime, well, you probably can't actually see this, but a lot of these are inputs where when the game does something, it sends a message into Pure Data. Want to talk very quickly about, because I realized that this was just a talk about, let's talk about some cool stuff in VR, but because this is a DEFCON local, I do want to talk briefly about security. So here's your 1 minute of security analysis of LÖVR. LÖVR uses Lua. Lua is a memory safe programming language. So similar to C# in Unity or C# in Godot or Godot script or JavaScript in Play Canvas, it is going to be harder to write unsafe code in this memory safe language than it would be in one of those old antediluvian languages like C. However, it is possible to write security flaws on purpose in LÖVR. In LÖVR, by default, you have access to the Lua FFI library, which allows you to access arbitrary memory or call arbitrary functions. It is possible to force use after free if you are writing the Lua code, which could lead to security flaws. And also, there's a sandbox where a LÖVR program cannot access any files outside of itself, but you can turn off the sandbox by calling one function. So the Lua code in LÖVR is considered trusted. It is assumed that when you have a LÖVR game, that someone is shipping a LÖVR executable along with some Lua code. They wrote that Lua code. They trust the Lua code. However, there are some things we could be doing in the future to adjust this. Lua has been used as a secure sandbox language, most notably in... Sorry, heard some interesting noises there. Lua has been used as a secure sandbox language.
That's Jersey City. This happens every stream.
Okay, great. Lua has been used as a secure sandbox language in most notably Roblox, which is a very, very large deployment. And I have a fork where you can have a compile flag to turn off the sandbox escape so the sandbox becomes solid for shipping code. That will probably be submitted back to LÖVR at some point. I also have a very weird project where I started re-implementing LÖVR in Rust just to see if I could. And the Rust plugin for LÖVR actually does have a safe mode where unsafe plugins like FFI are denied. So I want to show you one more cool thing, which at first is just going to seem really weird, but I'm telling you this for a reason.
We're all about weird here. Go for it.
Okay, great. So I'm going to warn you, if you are listening on headphones, just watch out for a moment. Hold on.
We shall be dead soon.
Hopefully not, but to launch something other than what I've been using. Right.
While they're typing this, we just want to note to everyone that we're going to be in Q&A shortly, so if anyone in chat has any questions, please let us know and we'll relay it over to our speaker.
I should have written this in a window ahead of time, and you know what? I did write this down ahead of time. I'm just going to copy paste this instead of trying to type on stream. Here we go. All right. So, all right. I muted this in voice meter. Here we go. Whoa! It's a little bit loud. Turn that down just a little bit. So I don't know if you can hear that, but what you are listening to is a MIDI module called the StrikeFET. And what is going on here is that this is a fork of LÖVR in which I attached audio synthesis and also attached MIDI support. So I just plugged in RT MIDI. This is to me what's great about LÖVR is that it's just a very, very thin C layer attached to the VR. So if I just want to drop in RT MIDI, I can do that. What this is doing is actually playing random MIDI notes. Sorry, hold on a moment. So maybe that doesn't sound all that good. I thought it sounds kind of creepy, kind of very. I could score a Paul Thomas Anderson movie with that. Take Johnny Greenwood's job. But the reason I'm showing you this is that this is part of a project that I've been doing where I'm actually creating an audio DAW in LÖVR without even using the VR parts. I'm just using this debug UI library I wrote, which is part of LÖVR, my open source release. By the way, everything I was showing you earlier, other than Skate Girl, is open source. But the reason I'm doing this is just because it was easy. There's something called Love2D. LÖVR is called that because it is based on Love2D, but with VR. Get it? But you don't have to use the VR parts. And I actually at one point thought, oh, I can share code between Love2D and LÖVR. But then I realized it was actually easier to just use LÖVR for everything. So the reason I'm showing you this is just an interesting thing I found is that game engines can be a really cool basis for arbitrary projects. Just things that aren't even necessarily game related, because think about what game engines give you. Game engines give you, rich audiovisual support. They give you support for strange peripherals that can be highly expressive, and they give you performance guarantees that are soft real time because they have to be able to do both audio and video, which are soft real time. So if you pick up, and usually they contain some kind of UI, like at least a debug UI. So you even if LÖVR isn't your thing, you could basically do what I did here, which is like one day think I want to write a script that plays random notes to a MIDI device. You could do that in Unity by just downloading a MIDI plugin. You could do that in Play Canvas by using WebMIDI. And what's cool is now you're in a game engine, and if I make my audio DAW in LÖVR and then I go, I want to do this in VR, I'm already in a VR engine. I don't have to rewrite everything for VR. So maybe you will see something come out of this DAW project. Maybe you won't. At the moment, it's just like some MIDI tools that are actually useful. So this is a thing that is very nice about having a extensible, flexible game engine at your beck and call, such as LÖVR. Or if you get really good with Unity, you could use Unity that way also. So that is all I've got. I've got some URLs here, which you may or may not be able to read.
We can read them.
But if anyone, it's great. If anyone has any questions, this would be a time to go ahead and ask them. The URL is over here. These are all the game engines that I mentioned. LÖVR and LÖVR's Slack. We are very friendly. And then some URLs that are just my stuff. Mermaid.industries. If you want to see more about LÖVR. Sorry, if you want to see more about Skate Girl, runhulu.com for my free games, and the third line is my my open source LÖVR stuff. But there's a list on LÖVR.org of open source plugins. Post the URLs in the Twitter thread. Yeah, I can do that.
Where
questions?
Are we sharing some of those links right now? Holy crap! One of the most frustrating things about running a DEFCON group is the fact that despite all the hacking stuff that I do, I feel incredibly useless after every single talk that people give at our things. I'm just correcting this URL that I wrote here. So the way we're going to do this is that if anyone has any questions, we're going to try to do like 5 to 8 minutes, and then we'll play the pre-recorded video of your colleague. Because we're already over time anyhow, because we're nuts. But it was really exciting to see this as someone who used to make video games as a career, to seeing all this creativity, both in terms of the actual development as well as the game design and audio design and interfaces. So what I'm going to do here is that I could ask my own questions if people don't have questions in chat. And if you do, please let us know, because we'll relay it. But what you didn't see this entire time is that Circe over here was basically jumping up and down the entire room, because this entire thing is every single thing that he likes. Like, if you could print the source code that you wrote for the game on a giant pillow, he will just like fall asleep with that forever. So what I'm going to do instead is I'm going to get out of this chair and I'm going to bring it over to DCG 201 member Ciricel and our co-founder GI Jack to grill you for their own questions. And if anyone has any questions, they'll relay them to you. So here we go. Yes, you are. Yes, you and you're going to do the audio thing. Disable desktop audio if you don't want it to reverb. Sorry, desktop the mic so it doesn't reverb when they're speaking. Right. Okay. So yeah. All right. You can come into the room. We all live together. Yeah. Yeah. I'm just. I kind of got through in here, and yeah. So let me just this real quick. Okay, check 1 2. I'm good. Someone asked how much of LÖVR is native versus Lua code.
So LÖVR is almost entirely C, but well, yeah, LÖVR is almost entirely C with a little bit of Lua bootstrapping. We've actually got exactly one Lua file named boot.lua, but all it really does is set up the environment. The idea is that LÖVR is a C API for that is exposed to Lua scripts. It is a harness for running Lua in. So it gives you some useful functions which are themselves implemented in C, and then you write your part in Lua. As far as the game that I wrote, actually started off because I was like, oh hey, LÖVR's in C, I know C. I actually started off by having a large portion of the game written in C. I actually just took an old platforming engine I'd written and just kind of shoved it in there. But over time, I've converted more and more of it to Lua. Basically, everything you saw in my demos in the MIDI, that was very nearly all Lua. Like the UI that I was showing with the editing, that was all Lua. That was just a little retained mode UI thing. That is and both the UI library and the MIDI stuff is in the open source stuff at the Mermaid LÖVR site over here. Hopefully that answers your question. I mentioned that I was re-implementing part of LÖVR in Rust. That was possible because, LÖVR is basically just like an API. It's like a series of functions that get supplied by our C thing, but it could be supplied by something else. Yeah, but at the moment it's basically LÖVR itself is written in C. No C++. Bjorn is very adamant about that.
Okay. Yeah. Thanks, Techno Babu, for the question. I guess question I have would be, how amenable is LÖVR to writing tools in particular rather than games? Like, so creating, for instance, a Doom level editor.
Well, so I mean, I did it, so it's not so hard. LÖVR itself is very minimal. It is the way that I usually describe it. I didn't get to this in the talk, but the way I usually describe LÖVR is that LÖVR is strongest as a rapid prototyping engine. So like in LÖVR, it doesn't give you some of the things that other engines give you. It doesn't, the UI stuff isn't built in, for example. If you want to reach out with a controller and grab something and pick it up and move it around, either you have to find a library that someone in our community wrote that does that for you, or you're going to be doing a lot of vector math yourself. Now I'm comfortable with the vector math, but if you're not, that could be a stumbling block. So if you want to do a UI, well, I was showing a bunch of complicated UI earlier. That was all stuff I wrote. So I have a Lua library, which is open source, so you can use it if you want. But I have a Lua library where I give it a list of descriptions of buttons and functions to call when the buttons are clicked, and it just shoves them on the screen. And that's my code, drawing a rectangle, drawing text in the rectangle, that sort of thing. You can do anything you want, but some things you're going to have to do from the ground up. So if you wanted to write a Doom editor, well, that wouldn't be particularly hard. You might want to have a small C helper to load the WAD, but you could parse a WAD using LuaJIT FFI pretty easily. Then you would basically just be looking at, well, either you're doing a lot of UI work yourself, or you just use my library because it's part of the open source stuff. Most of the LÖVR libraries that are out there right now are written in Lua. So it's kind of like all LÖVR gives you is the ability to do things like, draw boxes, draw text, draw lines, draw 3D models, use shaders, that sort of thing. But we have third-party libraries that do that sort of thing. And one thing that I will say that I didn't mention is that the UI stuff that I did, my UI library is now supported in 3D. So you could do your Doom editor in VR, in pure VR. It actually, LÖVR supports that a little bit better than it supports the stuff with clicking on the screen like I was doing during the demo.
All right, awesome. If anyone has any questions, feel free to post them in the chat. We're open for questions for the next maybe 3 minutes. One question that I do have in particular is that so Lua is a very capable, very powerful language that, I mean, a lot of people give it crap for having arrays index at 1, having weird syntax with this and that. But being a Lua developer, you can just rewrite all that to your own whims. But how dangerous can that be? Like, how much can that actually damage the engine?
I wouldn't describe it as dangerous. Lua is, do we support loading Rust modules in LÖVR? Talk to me offline. That ought to work, but we haven't tested it. So if you're interested in testing it, I'd be very happy to hold your hand through there just to see if it happens. We only added the ability for C plugins like last month. But now that we have the ability for C plugins, you should be able to make a Rust plugin because you can. There's ways in Rust to do that. So I would be very interested in helping someone bootstrap that. I'm sorry, I asked a question from the Twitch chat.
No, it's fine. No, it's fine.
I dropped off what you were asking. I'm sorry, what were we talking about?
I was just basically giving Lua hell for the sake of it, but
Lua. I look at Lua as the way I describe Lua is JavaScript if JavaScript were designed. Since JavaScript was not designed. JavaScript just sort of evolved through some kind of natural process. No human intended anything that happened in JavaScript. Lua is basically the exact same feature set as JavaScript, but it's been very smartly designed at every step of the way. It does have those two weirdnesses. You have arrays are indexed at 1, and instead of left bracket you say then, instead of right bracket you say end. Some people get really hung up on the syntax. Unfortunately, the syntax is the one thing you can't really change in LÖVR. You have control over, like, if you have an object and you say object dot something, you have full control over that, but you can't change then end. So that's a little bit too bad. But there's if you can't get over that, there are there's lots of open source game engines out there that support other things like C#, like JavaScript, like Godot made their own scripting language, but they also support C#. But it's not dangerous to do metaprogramming in LÖVR because you can make the metaprogramming very contained. So like the class system, for example, is something that was added by a library, but the class system only gets pulled in if you tell it to get pulled in that file. So like an old problem people used to have in JavaScript was that in JavaScript you could do things like edit the prototype for string, right? You could go and like change basic, like there was a lot of exposed metal in old JavaScript, and you could change like actually a lot of it in current JavaScript. In JavaScript, you can do things like change the functions on string. And if you do that, every library you've loaded is going to just break immediately because string is a global thing. In Lua, the metaprogram capabilities are much more contained to a scope, contained to a file, that sort of thing. Desix mentions one thing is that the people complain about the Lua indexing. They do it for a reason. You don't really think about it because you're rarely directly indexing stuff. You're usually using iterators. A thing that is really frustrating in LuaJIT is that if you are LuaJIT allows you to directly interact with C arrays or Rust arrays or Zig arrays or any C-like language. You can directly interact with memory from there. So first off, that is very dangerous. You can just scribble all over memory, but you're usually only doing that if you know what you're doing. You're not going to accidentally invoke the LuaJIT FFI. But one thing that is very frustrating is that this is far afield from anything, but a thing that is just a huge annoyance to me is that if you're using LuaJIT FFI, Lua arrays are 1 indexed, but C arrays are 0 indexed, and you're using both in the same file, which is just like, I'm just like, I don't know. I don't mind the 1 indexing, I just mind having a mixture of them in one file. But again, that's only if you're using the LuaJIT FFI, which is a very advanced feature. Although it's a nice feature to have because it lets you kind of break out of, it lets you break out of kind of the limitations of the Lua memory model. It lets you avoid some of the problems of garbage collection, for example. It makes it a lot easier to interact directly with C code in a way that is very annoying in C# or inefficient in C#, and that JavaScript kind of lets you do with like typed arrays and stuff, but it's not. There's a lot of kind of like, it's very indirect the way you interact with memory buffers in JavaScript, assuming that your VM even supports that.
All right, awesome. All right. Sorry if there's a bit of echo when I'm switching in between. We're kind of on half duplex at the moment, just to keep the echoes from getting out of control. So we're able to take one more question and then we'll move on. The side pocket should be back in about a minute or two or so. So yeah. All right, we got a question from Desix. So take it away. Take it away.
Is that the question in chat? The one
yes,
about,
the question in chat. One about JIT FFI using parser combinator.
That's more of a comment than a question, and yeah, no, that makes sense. If a problem, like, I mentioned a problem with Lua, and that's a solution if you're writing Lua. I like Lua. Lua's it's just a very, I've been using it for a long time. I actually, the LÖVR int library that I have open source for LÖVR, I have actually been using a version of it since like 2011. I wrote it originally for Polycode, and then I ported it to something called UFO, which is SDL based, and then I ported it to LÖVR. If you're writing Lua code, you can just kind of take it from engine to engine. I could probably use it in Roblox if I was interested in developing for Roblox, which I am. But okay, well, thank you very much. CC, and I guess our next talk will be Nevin, who is also a contributor to the LÖVR project.
So, Jack just had a quick question. What was that?
Yeah, well,
hold on, he's just getting aluminum foil for our tinfoil hats.
Yeah.
Okay, come over here. Come over. Ask it on here. Ask it on here.
So, can you cut it down?
Okay.
You need the headset, actually.
Well, I mean,
hold on.
It's gonna be complicated. Here.
Okay.
So it's half duplex. So when you're done asking your question, switch it over to desktop audio.
Okay, cool. Yeah, it is. There's a lot of, hi, what's going on? I have a question. Can you use this to visualize other data in programming? Like, let's say you have like a script that generates data, and you want to just generate like a virtual reality environment, but maybe it's like a bunch of points and in a line with some text that represents like process data output.
Make sure to switch it over when. Here, I got you.
I think I'll say is that a thing that. Am I on? So to answer your question, yeah, there is no reason why you could not do that. Essentially, a thing that I really like about LÖVR, and a reason that I like it over some of these other engines, is that Unity, Godot, Unreal, these are all based around scenes that are kind of retained mode. You create an object or something, and then you manipulate the object, you move it around. If you want to mesh, you have a mesh in a model and you pull it in. And a lot of these engines, a lot of their power comes from the fact that at runtime, you actually don't have all that much control over what's happening. At runtime, you're mostly limited to taking the entities that were in the file in the editor, in the scene in the editor, and manipulating them, moving them around. And this is great because it lets them do things like pre-bake shadows and do other advanced things that become possible when they have lots of information about the scene ahead of time. LÖVR is drawing the scene in real time every time. So if you call, in LÖVR, if you call, LÖVR.graphics.cube, 70 times, internally it is packing together all of those cubes into a mesh, and then it's sending the mesh to the video card. And if you want to bake stuff ahead of time, that's possible, but it doesn't do it by default. By default, you're just doing stuff live. To me, this makes it really easy to do very strange and complicated animations because you're not bound to things being the same. You're not bound to having the same meshes every frame. If you're doing dynamic meshes, you're not bound to having the mesh be the same size every frame necessarily. If I were wanting to do visualizations, the ways I would do this were you could just draw a bunch of cubes of different sizes and heights, a bunch of lines, that sort of thing. We have all these basic drawing mechanisms. Another option might be if you want to have something like a mesh that is changing over time, like you wanted to have like a 3D graph or something. It's possible to create a mesh object, like a model in memory, and be changing the points of the model in memory. That's getting to be a little bit more of an advanced technique. You probably need to understand a little bit about how 3D data is represented and that sort of thing. Making a mesh and manipulating it at runtime. You can do that in Unity or these other things, although in my experience, they really don't make it easy. They do not, those other engines, they don't want you to be creating things dynamically at runtime. They want you to be creating things in the editor and then only commanding them at runtime. And I know we're out of time, but just Desex Machina, we do not plan to add support for geometry shaders. Geometry shaders are usually considered outdated and inefficient. And sorry, I'll answer Desex's question in Twitch. But we have compute shaders, which is the new hotness.
Right, and yeah, those are my colleagues answering the questions for chat, and I'm just really blown away by this. I know it sounds like I say that for every talk, but this talk was honestly really excellent, and I'm really impressed with your work. And whether the game's for download or paying for it, I'm definitely buying it because I'd love to experiment with it. And
hopefully I'll have an announcement of a release date soon. It won't be too far away.
As I always tell the speakers, please at the end just let the audience know verbally where they can contact you. And if you want to submit other things that aren't LÖVR, any sort of hacker topic, you're more than welcome to send us more stuff. We'd love to have you back.
Thank you very much for having me.
Awesome.